Example 1 says, using the definition of the trigonometric functions, find the following trig function values. Now, we have part A says tangent of 120 degrees. So let's think about where 120 degrees is. I know that if I'm getting here, that's 90 degrees, and if I'm getting to the left side, that's 180 degrees. So 120 degrees is somewhere in quadrant 2. And it's going to look something like that. And the reference angle, I know 180 degrees minus 120 degrees is 60 degrees. So our reference angle is going to be 60 degrees here. And I'm going to draw the picture in quadrant 1 as well for 60 degrees. So that's 60 degrees. And we know that this is 120 degrees. Okay, so this is a special right triangle for 60 degrees, and so I'm going to fill in the coordinates here, and I know that that is 1/2 comma root 3 over 2. And so this coordinate here, it looks like it's just a reflection over the y-axis. So that means that I'm going to change the sign of the x-coordinate, and the y-coordinate is going to stay the same. Now, remember that tangent of theta is equal to sine of theta over cosine of theta. And another way of writing that is, remember, sine is the y-coordinate of the terminal point on the unit circle, and cosine is the x-coordinate. So this is the x-coordinate, this is the y-coordinate. That tells us that tangent of 120 degrees is equal to the y value, which is root 3 over 2, divided by the x value, which is negative 1/2. And I want to make sure that that is not a complex fraction. So I'm going to multiply by the reciprocal of the bottom fraction. And what ends up happening is this 2 and this 2 will divide out, and we will be left with the negative square root of 3 over 1, which is just the negative square root of 3. So that concludes part A. Part B wants us to find sine of 9 pi over 4. Now, I know that one full rotation around the circle is equal to 2 pi. So I'm going to subtract off 2 pi from 9 pi over 4 so that I can find its coterminal angle. So if I found a common denominator, I could multiply this by 4 over 4, and that would give me 8 pi over 4. So I'm going to rewrite that as 8 pi over 4, and that ends up being pi over 4. So it turns out that 9 pi over 4 and pi over 4 are coterminal angles. So if I'm looking for sine of 9 pi over 4, I can also find sine of pi over 4, and it will give me the same value. So this angle is pi over 4, and I know because I have so much practice on the unit circle that for pi over 4, the coordinates of that point are root 2 over 2, comma root 2 over 2. And remember, why won't you sign the prenup? Because you're still in love with your x. So sine corresponds to the y-coordinate, although in this case the y-coordinate and the x-coordinate are the same value, but still sine of 9 pi over 4 is equal to root 2 over 2. Part C wants us to find cosine of negative 60 degrees. So if I draw my xy plane here, positive 60 degrees will be right here. And I know the coordinates for this point are 1/2 comma root 3 over 2. And negative 60 degrees will end us up in quadrant 4 Here, this is negative 60 degrees, and I know this point here is 1/2 comma negative root 3 over 2 since it's a reflection over the x-axis. Now, cosine wants the x value, so that's going to be 1/2 here. So cosine of negative 60 degrees is going to be positive 1/2. Part D wants us to find secant of 16 pi over 3. And I know that I can subtract off a full rotation of 2 pi. And if I found a common denominator, I would multiply this by 3 over 3. And that ends up being 6 pi over 3. And so that gives me 10 pi over 3. But I can subtract another full rotation. And if I do that, I get 4 pi over 3. So let's see where that ends us up on the unit circle. So I know that 3 pi over 3 is the same thing as pi or 180 degrees. And so 4 pi over 3 is just pi over 3 more than pi. And so this here would be pi over 3 like that. And just to illustrate, this angle here would be 4 pi over 3. But the reference angle is kind of more important at this point. And so we want to figure out what coordinates are at this terminal point. And those are going to be, since we're in quadrant 3, both the x coordinate and the y coordinate are going to be negative. So those are the coordinates. And I know that secant of theta is the same thing as 1 over cosine of theta. So secant of 16 pi over 3 is the same thing as 1 over cosine of 16 pi over 3, or in this case, I'm going to use the coterminal angle 4 pi over 3. And that, according to this, we see that the cosine value is negative 1/2. So I have 1 divided by negative 1/2. And if we multiply by the reciprocal, that'll be 1 times negative 2 over 1, which just ends up being negative 2. So here, this thing is equal to negative 2. I have some spillage from the previous example. Okay, part E says cotangent of 855 degrees. In degrees, I know that 2 full rotations around the unit circle is equal to, well, if one rotation's 360 degrees, if I add 360 degrees again, that will be 720 degrees. So 855 degrees minus 720 degrees gives us 135 degrees. So this thing here is the same as cotangent of 135 degrees. Let's see where that takes us on the unit circle. I know 180 degrees is here. I know 90 degrees is here. So that's going to be right here. And our reference angle is going to be 45 degrees. So the coordinates for this point will be negative root 2 over 2, comma root 2 over 2. Now, cotangent is equal to cosine of 135 degrees divided by sine of 135 degrees, which is basically the x-coordinate divided by the y-coordinate. So I'm going to come over to the right-hand side here. Cosine of 135 degrees would be negative root 2 over 2, and sine would be positive root 2 over 2, but those are the same number, just the numerator has a negative. So that's going to simplify to being negative 1. So this is equal to negative 1.